Alright, this video we'll be talking about inscribed angles and polygons. So first of all, let's cover some vocabulary. An inscribed angle is an angle with a vertex on the circle and the sides both contain chords. So for instance here, looking at this angle here, I'll go ahead and label that. We'll call it X, Y, Z. Angle XYZ is an inscribed angle. You can see that the vertex Y is on the circle, not in the center, and it contains chords. We have a chord right here and a chord right here. An intercepted arc is the arc that's on the interior of the inscribed angle. So right here, arc XZ is the intercepted arc. Arc XZ is the intercepted arc for angle XYZ. An inscribed polygon is a polygon with all the vertices on the circle. So this quadrilateral here is inscribed in the circle because each of the vertices is on the circle. So that's my inscribed polygon. And then a circumscribed circle is a circle that has the vertices of the inscribed polygon. And so the circle on the outside is my circumscribed circle. So the measure of an inscribed angle is half the measure of its intercepted arc. So in my figure here, the measure of angle D, well, first you have to know which one is angle D. Oh, there it is, so it's labeled. Okay. The measure of angle D is equal to half of the measure of arc AB. And the measure of arc AB would be 2 times the measure of the angle. So if this was 35 degrees, then I know the arc has to be 70 degrees. So if we look at example 1, we're going to find the indicated measures. So first they want us to find the measure of angle S. So angle S is intercepting a 60-degree arc. I know the angle is half of the arc. So the measure of angle S has to be half of 60. And so it would equal 30 degrees. And then they want us to find RQ. So that one's a little bit trickier. RQ is right here. And at first glance it looks like there's not enough information. But I notice that I've got this inscribed angle here that's 37 degrees. And if that's 37 degrees, then that means this arc over here is 74. 2 times 37. And then the other thing I notice is that going from R all the way to S, it's a semicircle, so that's 180 degrees. So actually to find RQ, I can just take 180 and subtract the 74. And so the measure of arc RQ is 106. Okay, looking at another example. We're going to find the measure of HJ and the measure of angle HGJ. Alright, so I want to find the measure of arc HJ. Right here. And I notice that I've got an inscribed angle that's 39 degrees. So that means the measure of the arc would have to be twice that, or 78 degrees. So just writing that over here, the measure of arc HJ was 2 times 39, or 78. All right, then they want me to find the measure of angle HGJ. So now I'm looking at HGJ. Well, it's also intercepting that same arc of 78 degrees. So it's going to just be half of 78. Which takes us back to 39. So what do we notice? We notice that angle HGJ is congruent to angle HFJ. So that brings us to the next property, that if two inscribed angles intercept the same arc, then the angles are congruent. So we can see in this picture that angle D is intercepting arc AB, and angle C is also intercepting arc AB. And so because they are intercepting the same arc, I know that angle D is congruent to angle C. Angle D is congruent to angle C because they intercept the same arc. Alright, so if I look at this next example, I'm supposed to name two pairs of congruent angles in the figure. So if I look first at arc SR, I can see that SPR, or angle P, and angle Q are both intercepting that. So I know that angle P is congruent to angle Q. And if I look at the other side, I look at PQ, there I have angle S and angle R. So angle S and angle R are also congruent. Okay. Next, if a right triangle is inscribed in a circle, then I know the hypotenuse has to be a diameter. And so, right there in the figure, because if you think about it, I've got this angle, which is 90 degrees, intercepting this arc. And it's an inscribed angle, and so the angle is half of the arc, and this is a semicircle because the endpoints are a diameter, so this has to be a right angle. And then the converse is also true. If one side of an inscribed triangle is a diameter, then the triangle is a right triangle. So let's look at the next example. We're going to find the measures in circle M. So first I look here, I look at this angle QPN, it's intercepting an angle that's 118 degrees. And so that would have to be half of 118, or 59. And then I notice that one of the sides of the triangle here, NP, is a diameter. So that means that that angle and that angle, angle Q and angle O, are both right angles. And then looking over at the other side here, looking at angle PON, it's intercepting an arc that's 68 degrees. And so half of 68 means that this is 34 degrees. And then I can just use my triangle sum theorem to find the other angles in the triangle. So over here, angle Q and P, 59 plus 90, subtract that from 180, and I get that that angle is 31 degrees. and then do the same thing for angle NPO, and I find that this is 56 degrees. All right, now all I have left is the rest of the arcs. So I can see here that arc QP is with the 31 degrees. I double 31, and that's 62. And then you can double check, because you know this needs to add up to 180. And you can see that 118 and 62 do add up to 180. And then on the other side, I've got the 56 degree angle, so that makes NO 112. And again, just double checking, these also add up to 180. Okay, so a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Which again, if you think about it, logically it makes sense, because for instance, if I have angle A, it's intercepting this much of the circle, and then angle C, which is opposite, is intercepting the rest of the circle. And if the whole circle is 360, then half of that is 180, so they are supplementary. So in this figure, the measure of angle A plus the measure of angle C would equal 180, and it's also true for angle B and angle D. So we can use this property to solve problems. If we take a look at example A, I know that the opposite angles have to add up to 180. So x plus 88 has to equal 180. And so when you subtract 88, you get x is equal to 92. And then looking at the other opposite angles, y plus 100 has to equal 180. And so y equals 80. Okay, and then we're going to do the same thing on the next one. So I have 3y equal to 3y, or 3y plus 3y rather, and then 8x plus 4x. So let's start with our x's. 8x plus 4x has to equal 180. So 12x equals 180. And when you divide by 12, you get x is equal to 15. And 3y plus 3y is equal to 180, which means 6y equals 180, and so y would equal 30. And that concludes the video. Thank you.